In this video, we will calculate a binomial probability. A spinner that is 75% red and 25% green is spun 6 times. What's the probability of getting green exactly 2 times? So as a reminder, to calculate a binomial probability, where the probability that we are interested in K is N, choose K, where N is our number of trials, P to the power of K, where P is our probability of success, times Q, where Q is 1 minus P, to the power of N minus K. So now let's figure out from this problem what our different variables are. So we are asked about the probability of getting green exactly 2 times. So that thing that we're interested in 2 times is this value K. So K is equal to 2. And then our probability of green, that's what we are being asked about. That's our success. That's what we're considering a success in this problem. So what is P, which denotes the probability of success, which would be the probability of green? That would be 0.25. And then N represents our number of trials. How many times are we doing this thing? 6 times. And then Q, which is equal to 1 minus P, is 0.75. It's considered the probability of a failure, the thing that we don't want to happen, which is to get red. So let's plug in the numbers that we have. The probability that X is equal to 2 is 6 choose 2 times 0.25 squared times 0.75 to the 4th power, sorry I jumped there, N minus K, which is 6 minus 2. So to simplify that, 6 choose 2, 0.25 to the 2 power, 0.75 to the 4th power. So when I plug this in my calculator, that will give me the probability that we get exactly 2 greens. Now when you're looking at this formula, it actually makes sense. Because if you were to write this out, it would be 0.25 times 0.25 times 0.75 times 0.75 times 0.75 times 0.75. And this makes sense because we want exactly 2 greens. Well, there's green times red times red times red times red. So 2 greens and 4 reds. And then we just multiply their associated probabilities together. So that's where this part of the formula comes from. So what about this part of the formula? Well, do you see how I wrote down green, green, red, 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 red? Well, did it say that we had to spin the 2 green ones first? No. What if we spun the 2 green ones last? Okay, so there's another way we could do that. But you know, green could be here and green could be here. So how many ways can we arrange 2 greens among 6 different placements? 6 choose 2. And that's where that comes from. So this binomial formula takes into account each of the individual probabilities along with where they can be placed in what order. Just a little background on the formula so that it doesn't seem like this crazy thing that came from outer space. All right, let's actually plug this into our formula now, and we get 0.297. So there's about a 30% chance that we get exactly 2 greens out of a 6 times spinning the spinner.